Here's our Mech 588 project, a surface electromyography modulated haptic device for elbow torque proprioception. So our device is sensing the EMG signal from the bicep, and so with flexor synergy, which occurs in severe stroke survivors, what happens is that as they abduct their shoulder, there's an involuntary elbow torque that's generated in the flexion direction. And so this is caused by contraction of the bicep involuntarily. So we're reading activation from the bicep, passing that through several layers of filter, which extract the actual activation value from that signal. That's fed into a microcontroller, and the microcontroller is using that signal and then outputting a PWM signal with a duty cycle that is proportional to that analog input. That output from the microcontroller is passed to a motor driver here, and this motor driver outputs voltage that controls the rotational speed of this eccentric rotating mass, and as the speed of this increases, it increases the vibrational intensity of the motor. So essentially what we're doing is we're encoding this bicep activation into a haptic feedback signal with this motor. And so as you can see, as I contract my bicep, this motor will vibrate. And the idea here is that you could wear this in a sleeve. I'm showing it in kind of more of a loose form factor just so that it's easier to see this motor vibrate. But you could put this in a sleeve, and as the user involuntarily contracts their bicep during shoulder abduction, this motor would encode vibrational information that tells them how much they need to extend their triceps to counteract this involuntary elbow flexion. And so we've got pretty good resolution over the activation that we're able to measure. So as you can see here, I can kind of do low levels of activation. So just a little bit. But as I contract my bicep more, we can see even higher levels of activation. So there's a nice range of pickup on this signal. Thank you.